Okay, continuing on using the algebra tiles, what we're going to be looking at is multiplication of a binomial using the FOIL method. So what I'm going to be multiplying is going to be x minus 5 times x minus 2. Okay, and I modeled this, of course, by setting up our tiles using the same ones from last time. We have x minus 5, and then this is going to be times x minus 2. So we have to arrange this in some pattern. Okay, kind of a right angle pattern, so that way we can fill in the spot in the middle with what the product of these two binomials are. Okay, so what I'm going to do is just take this first one and move these down here. Okay, and then I'll just take my x minus 2 and we'll move that over there. So what's going to go in the center here is going to be the product of x minus 5 times x minus 2. Alright, well, looking at it, we need something that is x units long by x units long. Okay, and if you remember from last time, that's going to be our x squared. So x times x is going to give me x squared, so I know I have one of those. But now, what about the rest of this? Well, there's a whole bunch of space to fill in. Everything underneath the x squared has to be x units long, but it can only be 1 unit wide. So that's going to be some x's. Alright? Since we're multiplying a negative unit, or negative 1, times a positive x, they have to be negative x's. So since we have 5 of those, we're going to have 5 x's to line up. That way each one of those lines up. Okay, over here we have 2 units that also have to be x units long, so I'm going to need another 2 x's to go in here. Okay, well, now I have all of these spaces that are 1 unit long by 1 unit long going across, so I can't use any x's anymore, so these are where the actual units are going to be going. So I can start putting in some of these. And fill in this other row. Now we're filling these in positive because we're multiplying a negative by a negative. So of course that's why these are going to be positive. Okay? And that completes it. By the time we're done, we need to have something that resembles a rectangle. We can't have any gaps left in here or any spaces or anything like that. So our product is everything that we put into the middle here that matches the criteria based on the dimensions of our tiles on the outside. So if we count it, what we have is 1x squared, and then I have all these negative x's, which is going to be 1, 2, 3, 4, 5, 6, 7. And then I have these positive ones, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can see that the product of x minus 5 times x minus 2 is going to be x squared minus 7x plus 10. In that last problem, what we had was x minus 5 times x minus 2, and as we showed with the tiles, that gave us x squared minus 7x plus 10. So how would we just do this on paper? Well, we have what's called the FOIL method. And FOIL stands for first, outer, inner, and last. And this is just a handy way of remembering it. So we have FOIL. And the way that the FOIL method works is that if we have our two binomials, what we do is we start with the first terms, which is our variables, and we multiply those together. So our first terms are x times x. And x times x is going to give me x squared. Well, then I go to the outer. The outer is going to be the x and the negative 2, which gives me negative 2x. Then the inner is negative 5 times x. So I get negative 5x. And the last is going to be negative 5 times negative 2, which is positive 10. Okay? With any polynomial, the last thing that you're going to be doing is combining any like terms. So of course our two middle terms are like, they have the same x raised to the same power, so we can combine this and make it x squared minus 7x plus 10, which is what we showed using the algebra tiles. Alright, so let's try another one. In this case, let's take x minus 2 times x minus 4. So we're going to have x minus 2 times x minus 4. So if we want to represent this, of course, we need an x minus 2 times an x minus 4. Okay, and as we worked previously, if we take x times x, that's going to give us x squared, and we need to have something that is x dimensions by x dimensions to fit in here. Okay, we also need to have tiles that are x dimensions by 1 unit long, which is going to be our negative x tiles. And of course we're using negative because we're taking a positive x times negative 1s. Okay, over on this side we also need to have something x units long by 1, so I can put 2 more x tiles in. And because I have negatives times negatives, I can fill in these remaining spaces with positive tiles. So let's get a couple of those in there. Okay. And that fills up all of our spaces. So, using the FOIL method, if we took our first terms and multiplied them by each other, x times x, that's what we have here, x times x, which gives us x squared. Okay, our outside terms, I get negative 4x, okay, because I have negative 4 times x, so I get negative 4x. For the inside terms, I get negative 2x, so it's negative 2 times x, which gives me these. And for the last terms, I get negative 2 times negative 4, which is these negative 2 times these negative 4, and this gives me positive 8. Which, if we combine like terms, is x squared minus 6x plus 8. And if you count the tiles, that's exactly what we have. X squared minus 6x plus 8. Okay, let's say we try to factor a polynomial, in this case a linear equation 4x plus 6. So I went ahead and I represented 4x plus 6 using our tiles with 4 x's and 6 1's. Alright, if we're going to factor it, what we're going to do is we're going to start from the inside and we're going to see what we would multiply by on the outside in order to get these tiles on the inside. So first thing we have to do is arrange them in some sort of rectangular fashion like we had before. Okay, now I can't line up one tile to each of the ones because I have 4 X tiles, but I have 6 ones, so you can see I would have 2 left over. So of course that's not going to be rectangular. Okay, but I may be able to take each of these, because they can be divided in 2, and create my rectangle like so. Alright. So if I arrange the tiles like this, I still have 4x plus 6. I just have it arranged in a way that's a little bit easier for us to see. Okay, so now what I need to do is figure what would go on the outside, and those are going to be my factors. So I have to start laying tiles on the outside. Well, these tiles here are going to be 1 unit long, or 1x unit long. So I'm going to need something similar. So I would need some x units to go on the outside. The width, however, is only 2 units. And over here I have a width that's 3 units, so I have to have 3 units over there. Okay, so we can see that we have this factored. Alright, what we've done is we've factored a 2 out of this term, so I have 2 times, and if I look up over here, I have 2x plus 3. So my factored form would be 2 times 2x plus 3. Always double check and make sure that in your final answer in the parentheses that you have nothing else that you can factor out of there. And looking at that, there is nothing in common between 2x and 3. So this would be our final answer. This looks like a fun one. So what we're going to try to do now is actually factor this quadratic equation. And this quadratic equation is 3x squared plus 11x plus 6. So I modeled it with the algebra tiles. I have 3x squared, I have 11x's, and then I have my plus 6 over here. So the trick is rearranging this one into some kind of rectangle where there's no gaps or spaces, and then on the outside of that rectangle we're going to go ahead and fill that in with other tiles to see what the factored form would be. Alright, now looking at it, there's really no way to put this x squared off to the side or anything, so I'm just going to leave it here for the moment because 3 really doesn't factor into anything. It's prime. Okay, so all 3 of my x squareds are going to be in a row. But now as far as these 11x's, well, I can't line these up like this because those units have they don't line up. So I have to have something that looks like this. So I can try and divide my 11x's into 3 groups. Okay. So have my 11x's divided into 3 groups. But I still have 2 x's left over. Okay, well those 2 x's have to go somewhere. Okay, so I could take those and I could put them down on the bottom here because it has to be along something that is x units long. Okay, well, I have my 6 left over, and luckily I have 2 rows and 3 columns of these x's that are 1 unit long. And my 6 is going to fit in there. So I have my rectangle. So I know that I can easily factor this using the algebra tiles. So now all I have to do is go ahead and on the outside set up tiles that are the same measurements long. So since these are x long, I set up some algebra tiles that are x long and set one up there at the top. Now these down here are only going to be 1 unit in width. So I go ahead and just use some 1 tiles on the outside there. Okay, and that's going to cover the outside of my rectangle. So if I look at it, what I have is I have 3 x's plus 2 times 1x plus 3. Okay, and if you want to double check yourself, well, then you can use the FOIL method again. Okay, algebra tiles all map out, but if I do 3 times x, I get 3x squared. 3x times 3 is going to be 9x. 2 times x is going to be 2x. And my last 2 times 3 is going to be 6. And if I combine my like terms, I get my initial quadratic, which was 3x squared plus 11x plus 6. And for our last quadratic that we're going to factor, we're going to do x squared minus 6x plus 8. Alright, so again, I have to arrange this in a pattern that's going to form some kind of rectangle. So of course I want to start with my x squared. Okay, well, I could have all of the x's lined up with it, but these ones at the end are not going to line up. So I can't do that. So what I may have to do is move some of these over here. And I could try doing something like this. But if you notice, I have 3 rows and 3 columns. I would need 9 ones to go in there, and all we have is 8. So that's not going to work either. So if I try moving, let's say, one of these over, if I have 2 rows and 4 columns of negative x, then I only need 8 to go in there. So I can go ahead and move these in. And now I have my rectangle, so that's going to work. Okay? So now I need to see what goes on the outside, which is going to be the factor of x squared minus 6x plus 8. Okay, well, I have this positive x squared, so let me start by trying to put some positive x's here. Okay? But now I have some negative x's here, so it has to be something times the positive x to give me negative x's. So I'll put some negative 1's out there, since these are only 1 unit long. Okay? And then the same along the top here. I have a positive x here, but these are negative x's, so I need some negative 1's. And this works out because these negative ones times these negative ones is going to give me positive ones in here. Okay, so if we look at what we have on the outside, what I have is x minus 2 over on the left side, and on the top I have x minus 4. Which, if we multiply these two together, x squared for our first terms, outer negative 4x, inner negative 2x, and last negative 2 times negative 4, positive 8, and combine my like terms, I'm going to get my original quadratic, which was x squared minus 6x plus 8.